Hello everyone, welcome to our presentation on the topic properties of relation, transitive, reflective, and symmetry. This is a part of our CSC501 project. Our goal is to explore and automate the process of the identifying these properties in mathematical relation. Before we begin, let me show you the table of content. Table of content. First, we have group member. Second, background of study. Third is problem statement. Fourth, pseudocode of the system. Five, interface of the system. Six, result analysis. And last but not least is conclusion. We are a team of four members, each contributing to different part of the project. So first, Muhammad Hari Irfan bin Yahya as a group leader. Second is Muhammad Iskandar bin Muhammad Azhar as presentation administrator or editor. Third is Muhammad Shazani bin Muhammad Shakri, algorithm designer and researcher. And last but not least is me, Muhammad Zuhair Zakwan bin Muhammad Zakaria Anwar as a program developer.
Background of study. For background of study, we divide into 2 points. Point number one is equivalent relation properties. A relation RR is an equivalence relation if it satisfies three properties. Properties number one is transitive. If AB is a subset RAB, in R and BC is a subset RBC in R, then AC subset to RAC in R. For example is if 6 is greater than 4 and 4 is greater than 2, then 6 is greater than 2. Properties number 2 is reflexive. Every element relates to itself, means AA is a subset RAA in R. For example, 7 equals to 7, 8 equals to 8, and 9 equals to 9. Properties number 3 is symmetry. If AB is a subset RAB in R, then BA is a subset RBA in R. For example is, if AA is divisible by BB, then BB must also be divisible by AA. Otherwise, it's not symmetry. Point number two is key concept. A relation is considered as an equivalence relation only if it satisfies all three properties, transitive, reflexive, and symmetric. If any condition is missing, the relation does not qualify as an equivalence relation. Problem statement for this question is we need to manually identifying the properties of a given relation such as reflexivity, symmetry, and transitivity. Is a time-consuming and error-prone process, especially when dealing with large dataset. This inefficiency can hinder accuracy and consistency in discrete mathematics and computer science application. Therefore, there is a need for an automated system that can efficiently analyze and classify relations based on these properties while also generating their respective closure.
Bismillahirrahmanirrahim. Assalamualaikum. So right now I want to proceed with the sudoku of the system. So of course we want the program to start by asking the user to enter how many pairs of elements that they want to have using the scanner object. And after the system receives all of the uh, input from the user, it will collect and stores them inside the list of relation. And you can see from number 12 until 19, this is when the system will check for the three properties of relation involving reflexive, symmetric, and transitive. So if the conditions are met, it will print out whether the pairs of elements are either reflexive, symmetric, or transitive or not. Moving on to the next slide, this would be the pseudocode of calculating the closures, which is intended to ensure all of the conditions for every single properties of relations are met. So if the conditions are met, it will call the print closure method, and then it will display a message stating that the set properties are reflexive, symmetric, and transitive. So that will be the end of the program. You can see on the slide, these are all the functions or the methods that we use inside our program. We have all three: is reflexive, is symmetric, and also is transitive, to identify if the pairs of elements fall into any of these three categories. And on the right side, you can see the closure method to ensure if the conditions for every properties of relations are met. And last but not least, the print closure method, which prints the closure set in a readable format. So that's all for the pseudocode of the system.
Hi, my name is Muhammad Zahid Zakwan bin Muhammad Zakaria Anwar. So today I will presenting a Java program that show the relation properties. So first, as you can see here, we show the input user, and next for the output user, and here we show about the determine properties to show which is the set is a reflective, symmetric, or a transitive. And then here we show the properties check to show the is it reflective, symmetric, or transitive. And next, to generate a closure, and now we show the reflective closure, and if all are true, the program will show the set properties are reflective, symmetric, and transitive. And I will run some set for you. So we put 3, and the pair 1 is 1, 1, 2, 2, 3, 3. And here, as you can see, the set of element is shown, and then the property check, all are true, and no reflective closure. So the program will show the set properties are reflective, symmetric, and transitive. So that's all from me. Thank you.
For the interface of our system, we use Java as the programming language. The program starts by prompting the user to enter the number of elements in the set. After that, the user inputs pairs of elements which the system processes to determine the relation properties. The output displays whether the given relation is reflective, symmetric, or transitive. Additionally, if a closure is required, the program generates it automatically. One key feature of our interface is the clear separation between input and output display. The input session is structured to guide the user step by step in entering the elements, while the output session is neatly formatted to present the result plus with a symbol. These separations ensure that user can easily distinguish between the data they provided and the system compute analysis, improving readability and usability. For the analysis of the result, we conduct two tests, which is one where the relation successfully meet all the conditions and another where it failed, requiring closure to be added. Okay, first for the successful case, we tested the relation R equals to 1, 2, 2, 1, 1, 1, and 2, 2. The program correctly identified that this relation is reflexive, symmetric, and transitive. Since all conditions were met, no additional elements were needed for closure. Next is the failure case. We tested R equals to 1, 2, 2, 3, and 1, 1, where the output shows that the relation was not reflexive, symmetric, or transitive. In response, the system generated the necessary reflexive, symmetric, and transitive closure to complete the relations. This demonstrates that our system accurately determines the relational properties and suggests the appropriate closure when needed. In summary, these two results clearly demonstrate that our program works as expected and successful. It accurately evaluates whether a relation satisfies the required properties and provides the appropriate closure when needed. For the conclusions, our group project was completed successfully with the program we created to determine the relational properties of a set, checking if a relation is reflexive, symmetric, or transitive. It also identifies if any closure are needed. This highlights the importance of understanding equivalence relations in both mathematics and programming. Our program is user-friendly and provides accurate results, which can help students understand equivalence relations. Throughout this project, we improve our understanding of relational properties and their differences. However, we face some challenges. This program currently handles only on basic properties, needing a better user interface and could be expanded with more features and efficiency. Despite these challenges, we successfully debug and improve our program through teamwork and perseverance. We also learned the importance of time management while balancing this project with our other academic work. Overall, this project was a great learning experience. It helps us improve our collaborations, technical skills, and problem solving abilities. The knowledge we gain will be useful in our future studies and careers. That's all from us. Thank you very much.